There we go. Okay guys, today I'm going to show you how to set up and use the PIC microcontroller. These things are really great. If you know a little bit of C, you can get them to do just about anything. And it's much cheaper than the Arduino. The little chips run just about $1 or $2 a piece, to even less than that. There's some models that run just a few cents. So Microchip has their own proprietary development environment, and it's free, which is great. You can find it at microchip.com/mplab. So there's two things that we need to download. First is the mplab IDE, and that's the integrated development environment, and you can find that for your system here under downloads. The second thing we need to download is the XC compiler. Unless you want to program exclusively in assembly, a compiler is definitely something you need. So we'll go ahead and click over here and get the XC compiler, if it will ever load. There we go. And downloads are here. So go ahead and download the XC8 compiler for your system. After those have installed, and it takes a while to get those installed, we'll go ahead and start setting up the development environment. For a programmer, today I'm going to be using the PICKit 3. It works really well. It comes from Microchip itself. You can get them at Mouser Electronics, DigiKey. You can even get them on eBay for a little cheaper. But make sure you don't buy the off-brand ones. Some of them are pretty sketchy. And for our chip, we're going to use the PIC 16F684. There are plenty of them out there, but for this tutorial, this is the one I'm going to use, and it's real cheap. Has a lot of features and peripherals. So this is a very good chip to get started with. Is this PIC 16F684? The next thing we need to do is get our PICKit 3 programmer hooked up to our microprocessor. Now I'm looking right at the PICKit 3 user manual, and this will come with your PICKit 3 when you get it. The first thing I want you to notice is this little arrow right here. And this is the indicator for pin 1. So if we scroll down, we'll find the pinout for the PICKit 3 programmer, and you see that they have mClear, VPP, VDD, VSS. Now VDD is positive 5 volts, VSS is ground, PGD, DAC, clock, LVP. These are all programming pins. And if we go over to the user manual for the PIC 16F684, you will see that there are corresponding pins for that. So mClear connects to pin 4, and VSS and VDD, we've got clock here, we've got DAT there, and then program is not connected to this chip. So really all we need to do is hook up those 5 pins, and I'm going to leave that up for you to do. I've got a little breadboard and a pin header that I use. So that works pretty much for every microchip processor in existence. You just look up the pinout of the programmer and then hook it to the corresponding pins on the data sheet of the microprocessor. So now that we've done that, we're going to go ahead and open up our IDE here. The first screen you're going to see is the start page, which for me has been totally useless, so we're going to go ahead and close that. Now, just to note, I am not going to talk about programming in C today. I am not going to talk about ins and outs and analog to digital converters and all that kind of stuff. What I'm going to do is show you a very quick way to get off the ground and get into programming and get to playing with these things. So if you'll follow me step by step, I think you'll be pleased at how this turns out. We're going to go ahead and do File, New Project, and then we'll do a standalone project here. Click Next, and we'll select our device here in the device family. For me, it's the PIC 16F684. There it is. Click that. Hit next. We don't have a debug header. You don't really need one starting off, so if you don't know what a debug header is, just leave it alone. Click next. Select tool. We are using the PICKit 3. If we had it connected to our computer, it would have the device out there. Let's see if I can do that real quick. No, it's not going to load. So, oh, there it is. Okay, so we'll go ahead and select our device. Click next. Now, this is where we should see the XC8 compiler. The MPASM, or the assembly compiler, will always come with the integrated development environment, but we want to program in C because we don't want to lose our minds, so we need to make sure that the XC8 has installed correctly. If it is green there, go ahead and select it and click next, and if it's not, you need to go reinstall it, get it fixed, do whatever you got to do to get that back. So next, I am actually making a stair-step generator. Which is basically just a decade counter, but that doesn't matter. You put in your project name here, and then where you want to save it. These things are pretty self-explanatory. We'll go ahead and click Finish. Now here's where it gets where we lose most people. Alright, so you now have a project directory, but you don't have any source files. So the first thing that you need to do is click on source files and hit new and do C main file. And then we will type main as our new file. So this is the first file that we're going to type in, and for a lot of us it's the only file we're going to type in. And what that does is populates a new file. It includes these headers. Those are important to link other. Honestly, you can just leave them alone, but they're there to link other commands into this document. This is the main the main program function. If you've taken any C or if you've used any C, that's what this is. So we've got pretty much a blank slate here. But anyway, now that we've got our clean slate set up, we are going to configure the microchip. So we'll go up here to click Run and then select Configuration Bits right here, or Set Configuration Bits. Now you can do all this by hand, and some people do, but this is pretty frustrating for most people. So just follow what I do, and chances are it will be the same for your chip if you don't have the same one. The first thing is the only one that'll change really in the amateur world, and that is the oscillator selection bits. And there are 2 to 3 pages devoted to this in the data sheet for your chip. But most projects that I need to do not use an external clock or an external oscillator or anything like that. They just need to run off of an internal oscillator and be kind of close to on time. You don't need a crystal or anything. So if you're not using a crystal, set it to INTO-SCIO, which is internal oscillator, and it makes the oscillator pin an in-out function. The watchdog timer you don't need unless you know what it is. Power of 10 you don't need unless you know what it is. Clear you don't need. You don't need any of these following ones unless you know what they are. So we'll go ahead and set them all to off. Then we'll go down here and click this button, Generate Source Code to Output. And what that does is it spits out a bunch of code back here. We'll go ahead and close that and resize. There we go. So what that does is spit out a bunch of code down here at the bottom, and we'll go ahead and select everything from the pound sign all the way to the bottom of the document, copy, and we will go and put that directly under our other includes and paste that. So this tells the this tells the compiler to include all the instructions for the XC8 compiler. It also tells it to turn the oscillator off, or the it turns the internal oscillator on, and it turns all of this other junk off. Now that we've got our document prepared, the first thing we need to do is put some information at the top of our document. That way, 2 years from now, when we come back to this thing, we will be able to look at it and see what it was created, why it was created, and how it works. So I put my name, I put the date. We're going to put name of device, the function, and how it works in the function. So the name of the device is going to be the stair-step generator. Function is device creates stair-step waveform by outputting 0 to 7 cross bits RC0 to RC2. And this is another thing you need to do. You need to clearly define how what it's supposed to do, what waveforms are supposed to come in and out of it, and how it's supposed to work, because if you don't do that, you will get lost in code for a very long time trying to figure out how to do it. So draw out a schematic, write what comes in and out of this thing. If you can't clearly make this function up here, then you have not done enough prep work to start writing this chip. Cross bits 17, creating an 8-step for a Okay. Returning to the datasheet, let's talk about registers. Registers are places in memory where every microchip in the world stores information. Some of these registers are used to set up the device, and some of them are used to store information that you can move around and access and use for your program. But for every microchip, it has to be set up properly. Now, this is the list of setup registers for the device, and it looks pretty scary. But most of them are not important if all we're wanting to do is like light up LEDs, use buttons. Almost everything we need to do can be done with about 5 or 6 of these. So I'm going to click on each one of them and talk to you about what they do. There's the tri-state register, and that's the first one that we need to set up. You may have tri-state A, B, C, or D, or A and C in this case, but the tri-state register selects whether the pins on the microprocessor are inputs or outputs. Then you have the port registers, and you can have A, B, C, or D, or even more than that, but this chip only has 2, so port A and port C. Now the port registers determine if the pins are high or low. That is, do they have 0 voltage or 5 voltage? Also, most chips have some sort of comparator and analog to digital converters, and that is your ADCON and CMC on registers. So we will need to set these up, and if you just follow my instructions, I will show you just how to set those up for almost every PIC microprocessor. So let's go back to the IDE. To set up these registers, we're going to write our first function. So I'll write void because we don't want it to return any information. We'll call the name of our function initialize, give it no arguments, and open it up. So the very first thing that we need to program is the tri-state registers. Tris A needs to be set to 0 because that sets all of our pins to outputs. Tris C is set to output as well. Now this is where we would change it if we wanted to have some of our pins as inputs, but we're not doing that today, so we're setting them all to outputs. The next thing we need to do is turn off all of the comparators. So that is our CMC on register, and the only register we have on this chip for CMC on is CMC on 0. So we'll set that one to, actually I believe that needs to go to 7. If we set that to 7, that makes all pins ins and outputs. And then and select, this is analog select. This turns all of your pins to digital pins, so they're either high or low. And then your ADCON register. This chip only had one ADCON register. A lot of them have two, so look out for that. You may have an ADCON 1 you have to set up or set to 0. So we set that to 0 because that turns off all the analog to digital converters. The next thing we need to do is set our ports initially low. This won't do it forever. So port A is low. This means is your output high or low? Like, is it putting 5 volts out or is it putting 0 volts out? So we're telling it to put out 0 volts on both of these lines. Then the next thing we need to do is call this function in our main function. So we will say initialize. We will send no arguments and close our function there. Okay. Now, if we're going to do any delay commands or timing commands, we need to tell the compiler what our crystal is set to. And I don't know about you, but that's about 90% of what I need to do with these devices. Or if you're going to need to blink an LED, you're going to need to leave it on for a certain amount of time. So this is a very important command. And so that is define crystal frequency, and my internal oscillator is set to 4 megahertz. So you set that to whatever your crystal is set at, or whatever your internal oscillator is set at. And let's add our while loop. Now, we are finished setting up the chip. You can go ahead and start going to town if you know C. If you don't know C, I'll probably go over some basic commands in another video to get you started. But at this point, I'm going to go ahead and finish writing my program. That way I can show you the flash process and how you get it on the chip and the end result. So while 1 is true, repeat forever. Repeat forever while port C is less than 8. Open C++ colon. And this is one of those commands, this delay microseconds. This won't work if you didn't put in the defined crystal frequency. 489. Also, this delay in microseconds of 489, I found that the rest of my program, C equals 0, the changing states of the program causes, it takes about 21 microseconds. So I want this to happen every 500 plus 21 is 500. So that looks good. Now, when you are happy with your code, you need to make sure that your PICKit 3 is plugged into your computer, and that is plugged into your microchip device. And you need to make sure that your data lines aren't connected to some of your input-output lines. That is, make sure you disconnect some of your accessories, resistors, capacitors, and stuff that you have connected to your PIC microchip before you program it. It will make it a lot easier. So the next thing we do is we go up in here to File and go to Project Properties. we'll go to the PICKit 3, and where it says option categories, we need to go to power. This little box needs to be checked that says to power the target circuit from the PICKit 3. That will allow you to program it without any accessory power, and I'm going to set my voltage level to 4.75 because my computer does not supply the necessary 5 volts. You can actually bring this down to about 4 volts and it will still program. So if you're having trouble with that, you might try lowering this value, but if you can, leave it at 5 volts. But I know on my computer I have to set it to 4.75 volts. So we'll go ahead and click OK. And then we'll go up here and go to the Run Main project, and what that does is it compiles everything. It will give you any errors if you have any, and then it will flash the program to the chip. So let's click that, and you can see down here that it is linking everything. We have a successful build. It's connecting to the program. This error tells us to check and make sure that we are selecting a 5 volt device and not a 3.3 device, because if we try to program a 5 volt device and it's supposed to be a 3.3 volt device, it will burn it up. If you have a 5 volt device, don't worry about that one. So we now have it programmed, and after it programs it, it runs a verify, which means it pulls all the information back off the chip and checks it against the build here. So if you look over here in the corner, you see memory, and you can see that we've only used up 5% of our data, which is great, and program data is here. So this allows you to see if you're getting close to programming too much in the chip, but you can see that I've got plenty of room. So here's my setup, and you can see that my stair-step generator is working wonderfully. And for those of you that want to see the schematic, it'll come up on the screen. I hope that helped some of you. I know it was a lot for me to figure out, and don't forget to like, subscribe, and ask questions if you have any. And I'll see you next time. Thank you.